Welcome back to the final part about potential electric energy in this case. We've been discussing what potential electric energy is, what you should use as the distance in this case. Note the distance is always measured from the negative plate, and how you can assess the situation and look at when the displacement will cause negative work or positive work in which situation. Now technically there are 4 different situations that can occur. Situation A, we have a positive charge in this case, and the displacement happens to be to the left, meaning in this case your displacement delta x is to the left. Now this little thing just shows that is a vector. Do not be confused by it. You're still moving the charge towards the left in this case. Is this positive work or is this negative work? Well, the last thing you have to do is ask yourself what's the sense of my Coulomb force in this case. Now if it's a positive charge, your field vector E and your Coulomb force will have the same sense. Meaning, in this situation, the sense of your displacement and your Coulomb force is the same, so this is positive work when this displacement occurs. In situation B, we have a positive charge in the center. However, we do the displacement to the right in this case, so your delta x, it's going that way. Your Coulomb force has not changed compared to the first situation. It's still got the same, or it still has the same sense as your field vector E, meaning there is no way that the Coulomb force is moving this positive charge towards that positive plate. In this case, we talk about negative work. There's no way that the Coulomb force could do this. This has to be an outside source displacing this charge, not the Coulomb force. Situation C, you have a negative charge in this case. You're going to perform a displacement to the left in this case. Now, the one thing that changes is it's a negative charge, meaning your Coulomb force is going to have the opposite sense of your field vector E in this case. It moves in the opposite direction. Makes sense that a negative charge would be drawn towards the positive plate in this case. Now as you can see, the sense between displacement and your Coulomb force is again opposite, meaning this is negative work in this case. The last and final situation you can have is a negative charge. The displacement is to the right in this case. Now, what's the sense of my Coulomb force? I'm talking about a negative charge, so Coulomb force has an opposite sense to field vector E, meaning this one is going to be pushed alongside the displacement. This is something that can be done by the Coulomb force. So we're talking about positive work when this happens. Okay? Now, similar exercise, exercise 2. We bring a proton in point P here at the center, meaning we will have a positive charge in this middle point. And we will be moving it at a steady speed to 5 different locations. So location 1, 2, 3, 4, and 5. The distance that we move it is all the same. You can tell because it's a circle, and all the points are on the surface of that same circle. In which situations will the work be 0? In this case, when will there be no work done? In this case, well, the potential energy doesn't change if you just bring it up. Why? Its relative perpendicular position towards the negative plate will not change. So in this case, in situation 3, there will be no work done whatsoever. by that force. It doesn't change anything. Now, in which situations will the work be negative? Well, you can create negative work by displacing this proton to a position where its potential energy will be larger at the end than at the start, meaning it will be situations 2 and 1. In which situations will the work be max in this case? When will the force have the most positive work performed, the Coulomb force? Well, that is if you move it to situation 5. It is as close as it can get to the negative plate compared to the 4 other positions, so that's where it will go. In which situations will the work be negative? I again asked that one, apologies for that, it's the same one, it's 2 and 1 negative work. And in which situations will the proton end up with more potential energy that it started? Well, that is the definition sort of negative work. It somehow gains more energy, meaning you have to put in more energy, which makes it a negative energy in total, negative work. And that's again situations 2 and 1. I hope this helps to clear a few things up, and we will be talking about potential in the next chapter.